Welcome all for this video. So in this video we are going to learn about instruction set of 8085 microprocessor. 8085 microprocessor is a 8-bit processor. So it is easy to learn. So it has some instructions. 246 instructions are available. So we are going to learn about the instruction, what is instruction, what is instruction set, what is program. The next we are going to learn about what are the different types of instructions with respect to the size. So the next we are going to learn about the different types of instruction set depends upon the working. So then detailedly we can learn about the data transfer instruction. So inside the data transfer instruction we are going to learn some of the instructions in detail. So first we are going to learn what is instruction. An instruction is a binary pattern designed inside a microprocessor to perform a specific function. So initially when the microprocessor is developed, they are internally binary pattern is designed so for a particular function. So if you are entering the instruction, so it goes to the corresponding binary pattern. It responds for the binary pattern. So next one, a group of instructions together is called as an instruction set. So work similarity instructions. Work similarity means so for example, one data is transferred from one place to another means there is a data transfer concept is available. The concept wise the instructions are grouped together and that group is named as an instruction set. The next group of instruction set is called as a program. So to perform a task or to perform an operation, so we are in need of different types of instruction sets or grouped together to perform a task that is named as a program. Next classification of instruction set depends upon the size of the instruction. So according to the word size, it will be classified into three types. So 1 byte instruction, 2 byte instruction and 3 byte instruction. So 1 byte instruction means it has only 8 bits are available. So similarly 2 byte instructions and 3 byte instructions are available. So first we can learn detailedly about the 1 byte instruction. So 1 byte instruction means so in an instruction there is an opcode and operand is available. So both operand and opcode is present in a single byte means that is named as 1 byte instruction. So in different way we can think means there is in the instruction itself there is no numbers is present. So for example there is move c comma a. So it is it is represented with the binary code of 8 bit. And so this 8 bit is converted into hexa code, that is a 4f hexadecimal code. Similarly another example, add b, halt. So these all the instructions are named as a 1 byte instruction. So next we can see about the 2 byte instruction. 2 byte instruction means first byte specifies the operational code, opcode. Second byte specifies the operand. So commonly we can see means in an instruction there is a 2 hexadecimal numbers is present. So for example 2 instructions is available, MVI A, 32H. So this it has a binary pattern of 16 bit. So it is named as a 2 byte instruction. A similar way only second one also MVI B, F2. So it also a binary 2 byte instruction. It has 16 bit binary number. So it is represented as hexadecimal means 06H and F2H. The next we are going to learn about 3 byte instruction. So these all the classifications are depends upon the size of the instruction. So here what is the difference between the previous two? One means first byte specifies the opcode, second and third byte specifies the operand. So it has generally we can thought that. So how we can differentiate this one? So first 1 byte instruction there is no numbers is present. 2 byte instruction means there is only a 2 numbers is present. 3 byte instruction means there is a 4 hexadecimal numbers is present in the instruction itself. So from this we can identify the instruction size. So LXI load immediately, load register pair immediately H to 2050. So it has binary code of 24 bits. So from this 24 bits we can identify that this instruction is an 3 byte instruction. Similarly, next example also LDA load accumulator 3070. It also having 24 bit binary number. The next, so already we see about instruction is a binary pattern designed inside a microprocessor to perform a specific function. Now you clear about that what is binary pattern. So previous examples we know about 8 bit, 16 bit and 24 bit, depends upon the size. The next instruction set also, entire group of instruction that a microprocessor support is called as a instruction set. So it has a 246 instruction. 8085 has 246 instruction. So this is the classification of instruction set, depends upon the working. So first classification is data transfer, second classification is arithmetic instruction, third classification is a logical instruction, fourth classification is a branching instruction, fifth classification is control instruction. I am a little bit introducing about different sets. Data transfer means from one node to one point to other point. If any data is transferred, that is grouped together into data transfer instruction. So inside this, what are the transactions happens means from register to register, the data is transferred. From register to memory, the data is transferred, or memory to register, the data is transferred. These all the things are grouped together. So and named as data transfer instruction set. Next, arithmetic instruction. Arithmetic instruction means addition and subtraction is present inside this 8085 microprocessor. There is no multiplication and division operation inside 8085 microprocessor. So addition and subtraction is happens. So it is grouped together. So it has some more instructions also. So addition with the carry, addition with carry bytes, also having add immediately. So these all the operations are present inside this arithmetic instruction. Logical operation, and or XOR and NOT operations are present inside this logical operation. So logical performing instructions are grouped together and formed as a logical instruction. Next, branching instruction. Branching means jumping from one memory point to another memory, skipping. So that all grouped together into with the conditional jump, and conditionally the branching is also available. So it is named as a branching instruction. The next, control instruction. Control instruction means, so there is a control operations is available. So control operation making instructions are grouped together as a control instruction. So that's about instruction set. Next, we can detailedly see about the data transfer instruction one by one. Now we can see about data transfer instruction. Data transfer instruction, this instructions moves data between register or between memory and registers. So already I've said about the introduction about the data transfer. So data is moved from one register to memory, or register to register, or memory to register. So what happens means, if a data is copied from the source, it replaces the destination, but there is no change in the original data of the source. So there is a copying the data from source to and modify the destination data. So first one is a move, MOV, moving. So name itself we know about that. So something is moving from one point to another point. So here this is the opcode, MOV is the opcode, operand is RD means the destination register, source register. ERS means source register. Next M means memory and source register. Destination register and memory. So here what is the hub means? So the right end is the source register to destination, source register to memory, source is memory and destination. So for example, here one operation means M means, so it represents the memory, and from where it takes the memory content means the content memory locations is taken from the HL register pair. The HL register pair has 16-bit number, H has 8-bit number, L has 8-bit number. Totally it is combined as a register pair, and it is taken as a 16-bit address for the memory. From the memory address, so we are having some data in the memory address. The data is moved to the destination register. For example, so MOV B, C. It means C register content is moved to B register. So C content is not modified. Or MOV B, M. So M content is present in the memory. So address is taken from the HL register and it will be moved to the B register. This is the example of MOV B, A. So before execution, the A has 20 data. After execution, the A content is moved to the B register. Similarly, MOV M, B is the register, has 30 data. M is the memory. So 2050 is the memory address. So the B content is moved to the memory corresponding address 2050. Similarly, the third one also. Next, we can see about move immediately instruction. So MVI, the MV represents the move, I represents the immediate. Immediate means the data is present in the instruction itself. So here the opcode is MVI, operand is RD, data. So it is a 2-byte instruction. So it has some 2 numbers. So it is called as a 2-byte instruction. So 8-bit data is stored in the destination register or memory. So there is a destination register is available, or memory also a destination. So data is present in the right hand side. So for example, 60 is a data, so it is moved to the B register, or 40 is a data, it is moved to the memory. So memory location is taken from the HL register. So this is the execution. So MVI B, 60 means the B register there is no data. So no data means it is a 00 or any default value is present in the B register. After execution, the B register is modified into 60H. Similarly, MVI 40, MVI M, 40H means, so HL has 2050 means, so it is the memory location. So memory location, any other default value is available. After execution, the memory location is modified with 40H. Load accumulator. Load accumulator. So what is the operation of this load accumulator means? The opcode is LDA and operand is an 16-bit address. So we are loading the data from memory to corresponding accumulator location. The content of the memory location is represented as a 16-bit address. It specifies the memory location, and the memory location has some data in the memory. So the data is copied and transferred to the accumulator point. So here what is the thing means, it is a 3 byte instruction. So because of it has 4 numbers in the instruction itself, so that's why it is named as a 3 byte instruction. So this is the example of the LDA execution process. So 200 is the instruction represent address, memory address. So in this address there is a data of 30 is available. After execution the 30 is moved to the accumulator. The next we can see about register pair, load accumulator indirect register pair, load accumulator indirect. So X means it represents register pair. So we are know about that instruction register pairs are BC, DE and HL. So what is the means is there is no memory address is present. So depends upon the representation of the operand. So it takes from the register pair the address. So for example, if we are having LDAX-D, LDAX-D means, so DE is the register pair. From DE we can take the 16-bit address and goes to the memory location and take the data from the memory location, and it will be moved to the accumulator. So this is the example. So LDAXD, this is the example, LDAXD. So DE is the register pair, 20 and 30 is present in the register pair. So in the memory, so we are finding that 2030 memory location. In the memory location there is 80 data is available. So the 80 data is moved to accumulator. The next we can see about LXI. Already I tell about X means register pair, I means immediately. So load register pair immediately. Load the 16-bit data is directly loaded to the register pair. This instruction has 16-bit data in a register pair. So 2030 is the data. So 20 is moved to the register pair. H means HL. 20 is moved to the H. 30 is moved to the L. So LHLD, load H and L direct. Load H L direct means, so it is a 16-bit address present in the operand. So what is the thing means, loading H and H register and L register by using the memory location to 16-bit address. So next L is loaded with the corresponding 16-bit address. We incremented the memory location means next memory location into the HL. So this is the example of execution. LHLD 2030 means 2030 has some data 00. This 00 is moved to the L register. The next 2031 has a data of 85. So it is moved to the H register. Okay, thank you.